Welcome to Dhirendra Digital Solutions, your learning partner.
Hello friends, today we'll be dealing with gates. What are gates? This just as simple as the college gate that you have, a place wherein you make an entry or you make an exit, right? Same way, the electronic gates are meant for signals to make an entry or an exit from the system. Now, as far as the gates are concerned, we have basically three types of gates. In gates, we have three types of gates. The first one is called as basic gates. Basic gates. The second one is called as the universal gates. Universal gates. And the third one is known as the exclusive gates. Exclusive gates. Now, when it comes to basic gates, we have three of them. The first one is the NOT gate, which is also known as the inverter. The second one is the AND gate, and third one is the OR gate. Similarly, when it comes to universal gates, we have got two gates. One is called as the NAND, and the other one is called as the NOR gate. And when it comes to exclusive gates, we have two gates. First one is called as the XOR, and the second one is called as the XNOR gate. XNOR gate. Now, from here on, let us study what each one of these gates stand for. Now, let us first look at NOT gate. Now, all these things are with respect to the simple English terms that we have. When do we use not in an English sentence? Not is used to make a statement true to false and false to true. That means a word not will help you make a statement, give opposite meaning to that of what you are trying to say. Say, for example, I know English. I do not know English. So, not will help you change the uh, perception of the statement. Same way out here, when we come to binary logic, we have say one signal. Remember, a not is always used only on one statement. You cannot use multiple statements. So, one statement, you're going to use not. Same way over here, you're going to make use of only one signal, and let us call it as A as the input, and output is going to be Y. Since there is one input, we will have two possible values. One is 0, the other one is 1, because we are looking at binary number system. Now, if my input is 0, the not of 0 is 1, because the output is going to be opposite to that of the input. Similarly, if my input is 1, my output is going to be 0. Now, we have got the table over here. This particular table is called as the truth table of NOT gate. Truth table of the NOT gate. Now, with respect to NOT gate, how do we write the equation? Let us go back to the very fundamental way of writing equation. The very fundamental way of writing the equation is y is equal to, this is the output, is equal to the input combination A, and whenever we talk about 0, we represent it as A bar, the complementary structure, whereas 1 is represented as normal. Later on, we'll be talking about SOP and POS equations. There, I'll make it more clearer enough. But as of now, let us understand that for 0 we use representation as bar, and for 1 we use the normal variable. Dot. What is the output for 0? The output for 0 is 1 plus. What is the input out here? It is A. What is the output? Output for A is 0. We have written A over here because the input value is 1. A bar over here because the input value is 0. Now, 1 is nothing but the true state. If this is true, whatever is the other variable, that is what we are going to get. If my one part of the statement is true, then the output meaning will be dependent on the other part of the statement. That is why this entire term becomes A bar plus. Plus indicates the OR operation, whereas dot indicates AND operation. Now, A dot 0. If there are two statements, wherein one statement you are not sure whether it is true or false, whereas the other statement you are very sure that it is false, and you are using the word AND, then that means the entire statement will always be false. So the result is 0. Now, one part is 0, the other part is a variable, and the symbol used is plus. Plus indicates OR gate. Plus indicates OR operation. When I say OR operation over here, that means if one of the statement is false in an OR statement, then the total meaning of the statement is dependent on the first term. So my result will be equal to A bar. Now, in simple terms, most of the people would have told you for NOT gate it is Y is equal to A bar, because you have 0, look at the outputs which are ones and take that particular combination. But anyhow, this is how we fundamentally write the equation for the NOT gate, and this is how we derive the equation for the NOT gate. Now, what is the symbol for the NOT gate? The symbol for the NOT gate is a triangle, which we call it as buffer, and the NOT is represented by the bubble that we place in front. So this is your input A, this is your output Y, which is equal to A bar. So this is what is your NOT gate all about. The next one is your AND gate. AND gate. Now, as the name suggests, AND is a word that is being used whenever you want to combine two sentences in English. Same way, here, whenever we want to combine two or more signals, we make use of AND gate. Now, when we are combining two or more signals, say we have A, B. Let us start with two signals. And we have the output Y. Since we have two inputs, we will get four combinations: 0, 0, 0, 1, 1, 0, 1, 1. So these are the four combinations that we get. Now, 0 represents the false state of the statement, whereas 1 will represent the true state of the statement. Now, if one part of the statement is false and the second part of the statement is also false, then the overall statement, when combined, will obviously be false, and false is represented by 0, so we write 0. Similarly, the first statement is false, whereas the second statement is true. I am going to Mumbai, where I am not traveling, which is a false statement. And I live in Bangalore. I live in Bangalore, so I am traveling to Mumbai is a false statement, whereas I am in Bangalore or I stay in Bangalore is a true statement. So when I combine these two, since the first part of the statement is false, even though the second part of the statement is true, the entire meaning of the statement is false. Same way, since the first part is false, second part is true, so the end result is false. Similarly, if the first part is true, second part is false, your result is still false. The last possible combination is the first part of the statement is true, the second part of the statement is also true. So when you use and, the result will be a true statement. So the result is 1. Is that clear? Now, how do we go about writing the equation for this? Let us go back to a very fundamental way of writing the equation, which is y is equal to, y is my output signal. Now, a is 0, so a bar dot, b is 0, so b bar dot, output is 0, so 0, plus a bar, since a is 0, dot b, the statement is true, output is 0, plus, when you look at this becomes a, and this is b bar, a dot b bar dot, what is the output? Output is 0, plus a dot, here you can see this b, because it is 1, and the output is also 1. So we have discussed 0 represents falsehood, whereas 1 represents the true state. Since this is false, since this is 0, ANDing it with anything will give me a result as 0. So this will be equal to 0 plus, since this is 0, we get 0 here, plus, since this is 0, we get a 0 here, plus, since this is 1, since one of the part of the statement is true, the statement's meaning will be dependent on the remaining part of the signal. So this will become a b, or a dot b. Now, the first part of the statement is false, second part of the statement is false, third part of the statement is false. Remember, the plus indicates the OR operation. If any one of the condition is true, then the result is going to be true, the OR bit of the statement. Hence, this will become equal to a dot b, a dot b. This is what is AND gate. This is what is AND gate. Dot represents AND. Now, how do we represent the symbol? We have got two signals over here. So, two lines, two inputs. The shape of a D is being used, A and B over here, and this will be our output Y. This is how we represent our AND gate. Now, having understood the AND gate, let us go to the next basic gate, which is going to be OR gate. OR gate. Now, when it comes to OR gate, OR indicates one of the part of the statements being true, indicates the entire statement is true. For example, let us take again two signals. OR is also being used to combine two statements. Similarly, OR gate is also used to combine two signals. Since there are two signals, we will again have four combinations: 0, 0, 0, 1, 1, 0, and 1, 1. Now, if the first statement is false, second statement is false, and you are using the word OR, obviously the result is false. So, you represent the output as 0. Similarly, let us look at this. The first part of the statement is false, but the second part is true. Hence, the result is true. because we are using or. Then first part of the statement is true, second part is false, so it is 1 true. If both the part of the statements are true with the or word, it is going to be true. So this is what is our or gate. This is what is our or gate. This is the truth table of the or gate. Now let us look at the equation y. Y will be equal to 0, so it is a bar dot 0, so it is b bar dot output is 0, so we write it as 0, plus a bar dot b, since b is 1, b dot 1 plus, this is 1, so you get a dot b is 0, so it is b bar dot output is 1 plus, here we have a dot b is also 1, so we have b dot 1. Is this clear? Now let us look into the next step. Now dot indicates and anything ending with 0 or the falsehood is false, so we get 0 here, plus a bar b dot 1, that means the since one of the part of the statement is true and we are using the and, the output is dependent on the remaining part of the statement, so we get a bar dot b plus, similarly here it is a dot b bar plus a b. Is that clear? Now the next step, 0 ORed with anything, if the first part of the statement is false, then the total statement is depending on the rest of the statement. This is the first part that we need to understand. So I can write this as a bar b plus a b bar plus a b. Now what do we find common between these two terms? This a, so this will be equal to a bar b plus a, which is going to be common, into b bar plus b. Okay, and remember, when I'm using OR gate, if the first part of the statement is true and the second part of the statement is true, then it is equal to true. If the first part of the statement is false, second statement is also false, then the result is false. First statement is true, second statement is true, result is true. First statement is false, second statement is false, then the result is false. The other cases are a combination of one of them being true. But when we talk about both being true or both being false, false gives us false, true gives us true. So if I have a term known as AB, I can always write one more term called as plus AB. Is that clear? Now if I take these two terms, B is common between these two, so I can write this as A plus A bar into B. Clear? Now why did I add this? So that I can take common, and since I already have the term AB, I can rewrite the term AB again, right? So it does not make a difference in the equation. Now if the first part of the statement is true, second part of the statement is false, that means we are talking about 1-0 combination. What will be the result? The result will always be 1. So this is 1. When A is 1, OR with 0, you get 1. So I have replaced it with 1. So I get B over here. Plus, what is that we are doing over here? B bar plus B, that is 0, 1. For that, the result is always 1. So I can write this as A do 1 or A dot 1. When we say we are getting A dot 1 over here, when we say it is A dot 1 over here, anything ANDed with 1 is itself. So we get B plus, or here we get A. So y is equal to B plus A, or you can write it as A plus B. So this is what is the equation. And what will be the representation of this gate? This is the representation for the OR gate. It is a curvature that we have on all three sides. So it is A, B, and we have Y. Right? This is what is your OR gate. Please do comment, like, share, and subscribe. For more related videos, log on to www.dhirendradigitalsolutions.in. The link is available below.